Hi, folks. We've been talking about various types of chemical reactions. And one generic type of chemical reaction is the acid-base reaction. Now, in all truth, an acid-base reaction is really a double displacement reaction, but it is such a iconic, important kind of reaction that I want to talk about it separately from double displacement. And so we're going to talk about it a little bit right now. Acid-base reactions are typically going to occur in aqueous or watery solutions. And the generic form is like this. An acid plus a base is going to produce water and a salt. When we talk about a salt, we're talking about one of those ionic salts. Now, the generic form looks like this. And we're going to spend quite a bit of time here kind of breaking this down because this is a little bit more complicated than some of the other basic forms we've looked at. Acid-base reactions are often called neutralization reactions because this is how you take an acid and a base and you make them harmless. Acids and bases can sometimes be strong and corrosive chemicals. And if you mix an acid and a base together, what do you get? Well, basically, you can get salt water, which can be pretty harmless stuff. How do you recognize an acid-base reaction? There's a whole bunch of different clues, but one of the biggest hints is this. One of the products is going to be water. The other product is going to be a ionic salt. And in the reactants, the kind of acid-base reactions you and I are going to look at, one of those reactants is going to have an H, and that's going to be our acid, and one of our reactants is going to have an OH, and that's going to be our base. So let's talk a little bit more about each one of these components. Acids. Acids typically are made of a non-metal or anion. So those non-metal anions are things like chlorine, sulfate, carbonate. These non-metallic ions are going to be bonded with hydrogen. And that positive hydrogen ion plus those non-metallic anions are going to give you things like hydrochloric acid. Hydrochloric acid is the kind of acid that is stomach acid. Sulfuric acid is car battery acid. And carbonic acid. Carbonic acid is carbon dioxide that has been bubbled through plain old ordinary water, and it makes club soda or soda water. So when we identify an acid, it is going to be one of these non-metal anions plus hydrogen. And that's how we can help identify an acid. Now, there's a lot of chemistry out there, and everything bonded to hydrogen is not an acid. So this is just one piece or one clue to an acid-base reaction. The other clue is to see if we have a base. A base is typically a positive metal ion plus an OH, a hydroxide. Now, those positive metal ions can be things like sodium, potassium, magnesium, bonded to that hydroxide to produce things like sodium hydroxide or lye. Potassium hydroxide, which is commonly used when making a biodiesel. And magnesium hydroxide, group 2, much less reactive than group 1 metals, sodium and potassium, and it can make things like milk of magnesia. So in that acid-base reaction, when we look at our base, it's going to contain that metal, and it's going to contain that OH. So this is another clue or hint that we may have an acid-base reaction. That acid with a hydrogen, that base with an OH. And why is that H and that OH so important? Because they are both essential in making that product of an acid-base reaction, which is water. The other product in an acid-base reaction is an ionic salt. Now, back when we studied ionic compounds, a salt, if you recall, is when we have an metal and a non-metal ion from the metallic and the non-metal part of the periodic table. Those two things are ionically bonded together to give us some sort of a crystalline solid. When those things are bonded together, we get things like sodium chloride, calcium chloride, iron oxide, and originally the halogens were the salt producers. And we thought, the hundreds of years ago, they thought all salts contained halogens, and we now know that is not true. But these ionically bonded compounds are one of the products. When you take the other metal and non-metal, you've got that non-metal from the acid and that metal from the base. In that acid-base reaction, those two things combine and they give you that salt. In an acid-base reaction, typically those things are going to be aqueous and they're going to be swimming around in that water. So that gives us these really iconic kind of an acid-base reaction. An acid plus a base gives us water and a salt. So here's a typical reaction. Hydrochloric acid can be a very strong caustic acid. Sodium hydroxide in an aqueous solution. I have a picture of a solid lye here, but in my reaction, I have an aqueous version of that. And if these two react, the OH and the H combined to produce liquid water, and then the positive sodium ion, the negative chlorine ion bond and produce sodium chloride. The acid plus the base gives us water and a salt. And I like saying these generic forms out loud because there is a rhythm to them. And if you read them out loud, very often you can sort of hear what kind of reaction you have. Hydrochloric acid plus sodium hydroxide gives you sodium chloride plus water. You can sort of hear what's going on in that reaction. So let's use your beautiful brain and let's predict the products from this acid-base reaction. This is nitric acid, hydrogen nitrate, plus potassium hydroxide. I know this is an acid-base reaction, and I know out the other end, I'm going to get water and a salt, an aqueous salt. So let's see how this is going to work. So this acid is going to break right there, and this base is going to break right there. I'm going to end up with a hydrogen ion, and the NO3 is nitrate. So there's my NO3 nitrate positive ion. Here's my potassium, K. How do I know that's potassium's ion? Well, potassium is a group 1. Group 1, most common ion, is +1. OH, hydroxide. Hydroxides are OH -1. And the OH -1, the H+, that's going to combine to give me 2 H's and an O. That's water, and that typically is going to be liquid at room temperature. And what's left over? Well, you'll write the positive one first, the negative ion next. Whoops, that was supposed to be a negative NO3, my boo-boo. You have one of these, the charges will cancel. You have K, NO3. That should be aqueous. We can check on our solubility table, potassium, nitrate, wherever nitrate may be, and it says it's going to be aqueous, and that is our completed acid-base reaction. So once you have an idea of these typical reactions, you are a smart chemist. You can predict lots of chemistry and what's going to occur. Next time, we're going to come back and talk about some combustion reactions.